Joining us now in the studio is Dr. W. Frank King, General Manager for Advanced Engineering Systems at IBM. And next to Frank is Hugh Martin, Vice President of Development at Ridge Computers. Gary?
Apparently, you can give a pretty good comparison on the speed of this, because isn't there a coprocessor that runs in this machine that will run the standard 286 applications?
There is, Gary. This machine runs 1.6 to 2.1 million instructions per second. And it has in it a coprocessor board with a 286 on it that runs about a third of that speed.
Mm-hmm. Frank, what market is this machine aimed at? You've got this out on the market now for some period of months now. Who's buying the RISC machine?
We packaged a tabletop version of the machine primarily for those people that need speed and capacity above what the IBM personal computer and the personal computer type systems can support. So it's really for people who need more speed and more capacity.
Well, who are they?
Engineers is an easy example. Architects doing building design, people in the insurance industry that are examining actuarial tables, those kinds of people.
So you see business applications in addition to science engineering?
Yes, high-function business applications. Yes.
Frank, just for a reference point, what is the cost of this machine?
This machine, as it sits here on the table, is about $10,000.
Mm-hmm. And that comes with how much memory?
This has up to 4 megabytes of memory in it, and a big 70 megabyte file in it.
Okay, Frank, you mentioned design, and Gary, I'm going to put you on the spot now. I want to see how easy it is to use this RT PC here. You're going to be our operator, and you're going to help show off Frank's machine. Okay. Now, what can you show us on this, Gary?
Well, I'm an expert now. I've had a total of 10 or 15 seconds worth of instruction. I'm going to go in here and get a technical illustration. And so I select that and click on it, opens a window up. And here's a document of some sort with a vector drawing, I believe.
Yes.
And what I'm going to do is go and select this. And if I point at this little segment properly, got to get a hold of it. There it goes. It starts flashing. And now I can get a little menu down here, and I'm going to take this thing and rotate it. And as I move the mouse around, you can see that the object itself is moving, and then I can just leave it in that position.
Okay, and that real-time rotation, I take it, is an example of something that's requiring a lot of fast processing to handle that.
Mm-hmm. That's right.
Or I can pick up a piece right here, for example, to get a hold of it. And my hand-eye coordination isn't that good. Okay. Well, there it goes again. Okay, now what I'm going to do at this point is I'm going to take the thing and move it around. We're going to take it and slide it down to this portion of the screen. So you can see the action there is pretty nice. And then just leave it.
Frank, one of the concerns I've heard about the RISC machines is the problem of adapting software and so on. Where do you stand on that? Do you have to write new software just for this?
Not really. Most of the software that runs on this machine is written in a high-level language. And so the compilers have to be there to support it, and you do have to have compilers that know how to work with RISC architecture. But the compiler really masks moving the current software to this kind of machine.
This is basically a Unix operating environment?
Yes, this is basically a Unix operating environment that supports C and Fortran and those kinds of standard languages.
What's your strategy for moving applications over? We talked with Hewlett-Packard about that. What's your...
Well, first of all, we define a set of compilers, and those are the normal compilers. And then the price performance of the machine has to justify people wanting to spend the money to move their software to it.
Mm-hmm. You have a small company, Ridge Computers, and I think you've sold 400 or 500 of these RISC machines. Who are you selling them to, and how are you carving out a niche among the HPs and the IBMs?
Well, our niche is primarily price performance in a technical marketplace. A primary example of a customer you may be familiar with if you've seen the Super Bowl or the Olympics. All the animation that precedes those programs were done by a local company, Pacific Data Images. They have 12 ridges doing nothing but cranking frame after frame.
Once again, the heavy-duty graphics requiring the speed and the power that RISC can give them.
Yep.
Frank, where do you see going next? We hear rumors of an enhanced RT PC coming out and some changes in it. Is that true?
Well, certainly IBM never talks about its futures, so I have to start out by saying we're not going to talk about our futures. But what we see going on in this industry, the desktop microcomputer industry, is really a doubling of speed and capacity about every 12 to 14 months. So clearly, if we're going to participate in this marketplace, and we intend to, that kind of improvement over time has to be sustained.
Now, we're seeing some pretty substantial improvements in speed on the 286 and 386 side. Isn't that pretty competitive with the RISC architecture? Let's say a 24 megahertz 386. Isn't that pretty close to the speed of this machine?
The 386s that are available today, of course, are 16 megahertz. But as the Intel architecture becomes faster, in order for this kind of a machine to justify the price and the price performance, it's going to have to stay faster, and that is our intention.